Hello, welcome back to another science video by your science teacher today, Mr. Long. Now, I'll be going through the PSLE paper 2023, and I'll be going through the second part of the paper, which is a physical science question from question 35 to question 40. If you have not watched part 1, which is on the life science portion, please check out the other video. Right, let's go to question 35. As a reminder, if you have not attempted the questions, please do so first before watching this video. And if you have done it and you just want to have a refresher or you want to do your corrections, please feel free to watch this with your green pen in hand. Now, Ali sprayed some hand sanitizer on his hand. State why Ali's hand became dry very quickly. Of course, the idea of hand sanitizer is familiar to all of us who have gone through COVID, and you know that that contains liquid. Therefore, in your hand, your hand is your part of your body, and your body temperature is about 36, 37 degrees Celsius. Comparing the temperature of both substances, of both things, your hand and the sanitizer, of course, your hand is at a higher temperature. And the liquid in your hand sanitizer, when it touches your hand, the liquid will gain heat and it will evaporate into a vapor, a gas. So therefore, the liquid in the hand sanitizer will gain heat from his hand, Ali's hand, and evaporated. Right? That's the idea behind why it became dry. Now, Ali sprayed hand sanitizer on his hand again and blew on it. I emphasize the blew on it part. Explain why his hand felt colder than before. If you've watched my videos, I will explain that part A of your science question usually the part that gives a hint to the rest of the question, right? To ease you into the concept being tested. So part A is about evaporation, right? So part B, therefore, is also about evaporation. And blowing on it, this will be your rate of evaporation. And there are three factors that affect the rate of evaporation: the presence of wind, temperature, and exposed surface area. And which of these three is it? It's presence of wind. So blowing on the hand sanitizer increases the rate of evaporation. That is 1 mark. Okay, I explained the blowing part. Now, how to explain the feeling colder part? Let's go back to part A. How does the evaporation process happen? Only if the liquid gains heat. If the liquid gains heat, means Ali's hand must have lost heat. If you lose heat, you feel cold. And therefore, the hand sanitizer gained more heat from his hand. The idea of more has to be present because here, this is a comparative, right? Colder than before. So earlier on, he also felt cold. But now why is it colder? Because he lost more heat. Now, next one. Thomas carried out an experiment with a toy boat. He turned the propeller to twist the rubber band before releasing the boat into a bathtub filled with water. He measured the distance moved by the boat. There was no wind during the experiment, and the results were shown. Very straightforward relationship, right? As he increased the number of turns of the propeller, the distance moved, and the first try increased. The distance moved on the second try also increased. So state how the number of turns of propeller affected the distance moved by the boat. As the number of turns of propeller increased, the distance moved by the boat increased. Now, how would the energy conversion be like? So the elastic potential energy, you don't need to write elastic, you can just write potential energy, right? But I prefer to write elastic for teaching purposes. The elastic potential energy in the rubber band converted to the kinetic energy in the propeller. At the same time, as it moves in the water, there will be sound, or you can say frictional force, so there is some heat generated. Of course, the boat itself, because the propeller is moving, the boat will move at the same time. So there will also be kinetic energy. Be careful not to use forces here. This is about energy conversion. So just the reason why the distance moved for both tries are different for 20 turns of the propeller. Well, simple. The boat may not travel in a straight line every time, no? This is water, it's not a track on land, right? So it can swerve to left or right. And the water can contain waves that can affect how fast or slow this boat moves. So this will be the answer. The waves are different every time, or the boat may not travel in a straight line every time. So let's move on to question 37. Now, Mamie cooked some vegetables using oil F in a heated pan. She measured the temperature of the pan before adding the vegetables until after the pan was washed. Her results are as shown. Now, you may find the language here troubling if you don't read widely enough, but that's fine. So just use common sense, right? Before your helper or parent or grandparents fry something, they don't put the pan there and throw vegetables in straight away. They must heat it up first. So the first part, they turn on the knob, right? Or they turn on the gas stove, and the pan heats up really quickly and fast. And then they throw in the things inside to fry, whether it's an egg or vegetable or meat. And that is usually not cooked, correct? And it's usually at room temperature. Or from the fridge, it could be a bit cooler. And that's why the temperature will drop in the initial part when that vegetables touch the hot pan. Because the colder vegetable will gain heat from the hot pan. The hot pan will lose some heat to the cold vegetables. That's why they see a dip here. And that's how I know the time at which you put the vegetables in the pan. The time is around 1 minute, or you can say a few seconds after 1 minute. Now, if you just say after 1 minute, I don't know what you're talking about. Is it at 2 minutes or 3 minutes or 4 minutes or 10 minutes? Because all these minutes are after 1 minute. So you gotta be quite precise, like 1 minute or maybe 1.1, 1.2, 1.3 minutes. No? Now, what's the room temperature? Now, room temperature would be the temperature of the room. And that's after all things are done and washed. So you see, room temperature will remain kind of constant. So this will be a room temperature. And this line here is between 20 and 40. So this is 30 degrees Celsius. Please state the units, no units, minus half a mark. Remember the pan was already washed, right? Means the pan must have cooled down to allow the helper or mommy or grandparent to wash it. Or hopefully you are the one who washed it. Let somebody cook and you do some things at home and you wash it. And help to do some household chores. Now after cooking, she poured the hot oil into the sink. Oil F has a melting point of 40 degrees Celsius. Interesting, right? You see, oil, in your mind, you think of a liquid. But here it says melting point. Isn't it solid that melts? It's true, but a substance can have many states like water. You think of water, you think of the liquid water. But water can also be in ice, can also be water vapor. Now, what does melting point mean? It means that when oil F is a solid, to turn it into liquid, you need to heat it up until the temperature of oil F reaches 40 degrees Celsius. Then it will change state and melt, which means at any temperature under 40 degrees Celsius is a liquid. Sorry, at any point in time, at any temperature under 40 degrees Celsius, it is a solid. Okay, pardon me. F is a solid at temperature under or lower than 40 degrees Celsius. Now, several months later, the water pipe below the sink was blocked by a solid at X. And this solid X, of course, is the oil F. How did the solid come in? Explain why a solid was formed in the water pipe even though the sink protector prevented solid waste from entering. Now, usually you have something there, right, at your sink, some metal dish, small things with tiny holes. There to catch all the solid debris like the leftover rice and vegetable and bits and pieces from going inside your water pipe and clogging it up. It's a problematic if it clogs up. Now, here, so your parents may think it's okay to pour hot oil in. Now, oil goes in. Now, here, hot oil, right? Hot means it is above 40 degrees Celsius. What does it mean when hot oil is above 40 degrees Celsius? What state is it in? It's in liquid state. Of course, liquid can pass through the sink protector because that is meant to catch solid waste. It cannot catch a liquid. So therefore, the hot oil is a liquid. So it could pass through the sink protector and enter the water pipe. That explains the first part. Because explain why the solid can form in the pipe even though the sink protector prevented the solid waste from entering. So this red color portion explain this part. 1 mark. But I haven't talked about the solid, right? Remember, once it cools down, once oil F cools down to a temperature below 40 degrees Celsius, it solidifies. It turns from liquid into a solid. So when the oil cools down in the water pipe, and the water pipe should be at room temperature, which is lower than 40 degrees Celsius. So when oil loses heat, or when oil cools down in the water pipe, it changes state to a solid. Okay. Now, question 38. In the circuit shown below, P and Q are identical bulbs. All the components are working. Now, when switch S is closed, the iron bar moves up and down between points A and B, and the bulb P turns on and off repeatedly. Explain why the iron bar moves between A and B repeatedly. So let's understand the mechanism of this thing first. So there's a circuit here, and there's another circuit inside here. It's a parallel circuit. And here you notice a fixed iron cylinder. All right, when switch S is closed, current can then flow like this through the contact iron bar, right? Once it can flow, it means that these coils here will create a magnetic field. They will turn the iron cylinder into an electromagnet, part 1. And that will attract this iron bar upwards. Once it moves up, it will break away from the metal contact, right? There'll be a gap here. And this part will now touch these two other metal contacts to close this circuit. Then now, what happens when it goes up? Q remains lit, but P no longer remains lit because P can only light up in this if this outer circuit here is closed. But once this one goes up, it cannot be closed anymore. And once it leaves, this iron cylinder becomes demagnetized, and this iron bar will fall again. Then you will touch these two, and the whole cycle repeats. So that's how we are looking for your marks. Part 1 is about explaining how did the iron bar goes up. Part 2 explain how did the iron bar comes down. You see, explain why the iron bar moves between A and B repeatedly. It must go up, must come down. How does it go up? Step by step. When S is closed, current flows through the circuit. See? When S is closed, current flows through to light up P and Q. And it magnetizes this iron cylinder. The P and Q is not important for this question because there is no need to talk about the bulbs for part A. It's only talking about iron bar. So you don't have the lighting up P and Q, that's fine. So S is closed, current flows through the circuit and magnetizes the iron cylinder, which then attract the iron bar upwards. Once the iron bar moves up, the circuit is now open. If the circuit is open, the current stops flowing and P stops lighting up. Again, you have to mention this because this is not meant for part A. So once the iron bar moves up, the circuit is open, current stops flowing, the iron cylinder becomes demagnetized and the iron bar falls back to close the circuit to here, okay? Now I explain goes up, goes down. Now state which bulb is lighted or unlighted when iron bar is at A. The reason why I wrote this here is to help me to answer part B. So when the iron bar is at A, which is at the bottom here, current flows through like this, the outer circuit here, and P and Q therefore both lights up. Now when iron bar is at B, state how the brightness of the bulb Q changes. Explain your answer. Now you'll notice these two bulbs are in series, right? So if this one goes up here, now these two battery will only light up this Q. That's all. The current just flow here, this smaller circuit, when the iron bar is at B. But if the iron bar is at A, now these two battery must send current to light up the bulb Q, P, and go through all these wires. So less electrical current will flow through Q and when the iron bar is at A. And more electric current can flow through Q when it is at iron bar is at B. So when something's become brighter, it's usually because there is more electrical current flowing through it. So bulb Q becomes brighter as more current flow through bulb Q when the iron bar is at B. Question 39. Can I set up the electric circuit in a toy using identical bulbs and batteries shown below? And all the electrical components in the circuit are working. When it closed the switch, the bulb did not light up. So asked to use a pencil, please, common sense, pencil means if you make mistake, you can just erase, okay? Now, you can correct the mistakes that this person made, and you have two conditions. First one is to correct mistake. Second one, you have these two conditions. If one bulb blow, the other one will be lit. That means that it has to be, the bulbs must be arranged in parallel. And the bulbs will only light up when the switch is closed. Plural, so both bulbs must light up when the switch is closed. Notice here, 3 marks. 3 marks means 3 marking points. Okay, very simple one, right? When we mark this paper, we look at, okay, do you answer the first thing, second thing, third thing? What's the first thing? Do you spot the batteries were arranged wrongly, wrong orientation? These are all in series. You notice they purposely arrange this way to make you think they're in parallel, but they are not in parallel. See, wires come here, it snakes over here. It's in series. So therefore, I must rotate one of the battery around. Can be either, you can flip this around, okay? So plus, minus, minus, plus to show you the correct polarity. All right, if I arrange the battery correctly and I fix them with no gaps, yeah, 1 mark. Next thing I should spot that, hey, this at first, how come the wire only touch the metal tip, didn't touch the metal casing, didn't touch the metal casing? I must make sure my wires at both ends touches. One touches the metal casing, one touches the metal tip. One touches the metal casing, one touches the metal tip. If I have done these two for both bulbs, another 1 mark. Last part, I must fulfill the condition of my bulbs in parallel. Okay, so my bulbs are in parallel. If I on this switch, current will flow and light up both of these. My switch can be here, can be here, can be here. All right. If you put a switch on this wire or this part, then it's wrong. If you put a switch here, it means, well, this side is always closed and the bulb is always lit. Okay, so the switch must be either on this wire or this part or this part. All right, and the switch can also be here on this wire. But it cannot be on this wire. The switch cannot be here. The switch cannot be here. Now, last part, state what boilings mean. Now, this is a common question for the past few years, common type of question, asking for definition. State what evaporation means, state what condensation means, state what pollination means. So you got to know and memorize these definitions. State what temperature means, state what heat means. What's boiling? It's a change in state of liquid to a gas at fixed temperature. Now, don't talk about water. Don't talk about 100 degrees Celsius. This is not what boiling of water. It's not about boiling of water. It's just boiling in general. So you mentioned about water. Sorry, it's wrong. Talk about 100 degrees Celsius. Sorry, that's wrong. Okay, but you must mention change in state, liquid to gas at fixed temperature. Now, engineer wanted to test if an electric pot or hot pot, steamboat, can be used on a table with a thick glass top. He heated water in a pot for 1 hour. So thick glass top here is on top. Thick glass top. You have done question before on thick glass wall glass, okay? Earlier year questions. Try to remember how you answer those questions. Explain why part A of the glass top was hotter than part B. Part A was nearer to the electric pot, nearer the heat source. Part B was further. But we simply just say part A was near to the heat source. It's not enough to explain why it was hotter. Now, remember what is glass? This is on heat, right? What's the property of glass? It is a poor conductor of heat. So yeah, part A can gain heat from the electric pot quite fast because it's near to it. But for the heat to travel to B through this poor conductor of heat, it's really tough, okay? It's really, really slow. So therefore, part A will gain heat faster, whereas part B gain heat slower. Therefore, part A will always be hotter than part B. The 1 mark is for the second bracketed part here. Now, the glass top cracked after some time. Explain why. Well, the top of the glass gain more heat, right? The top is the top part, gain more heat. And therefore, it expanded more than the bottom part. Bottom part is here. That's half mark. So what if some part expanded faster, expanded more than the other parts? Well, this uneven expansion will cause the glass to break. I'm sure you heard this phrase many, many times from your teacher. Uneven expansion, all right, will cause the glass to break. Now, if you just memorize by heart and you say uneven expansion and contraction, then that is a wrong concept. There's no contraction mentioned here. Nothing is being cooled down here. Then you wouldn't get a second half mark. All right. That ends the second 20-minute lesson for you. All the best in your preparation for your PSLE or your prelims. Take care. I'll see you in the next video.